All right, guys, this is a little review of what we've done the last couple of days, just making sure you understand the basics before we get into more in-depth stuff with it. So the first thing you need to know is your terms. There are three types of fractions: a proper fraction, an improper fraction, and a mixed. Proper fraction is when the top number, which is the numerator, is less than the bottom number, which is the denominator. This is a true fraction. It gives it a decimal answer because all fractions represent parts of a whole. All fractions like this are decimal numbers. Really, this is 1 divided by 2 equals 0.5. But make sure you understand that proper fractions are always representing something that's less than 1. An improper fraction is a fraction that has a higher numerator than the denominator, and it'll be a partial decimal number, but it'll have a whole number first. So 3 over 2 is 1 and 1/2, it's 1.5. You don't have to worry about that for a few more minutes, but an improper fraction is when you have a higher number on top and on the bottom, your numerator is higher than your denominator. And finally, mixed is another common way to see fractions. A mixed has a proper fraction here, but alongside of it is a whole number. So that whole number is a complete set of something, and then added on to it is a fraction. So when you look at it, and when we learn to change these into numbers, the whole number would be 1, and then it would be decimal 25. 1 divided by 4 is decimal 25, and together 1 1/4 equals 1.25. So 3 types of fractions: proper, improper, and mixed. Down here, we just reviewed that, making sure you understand that fraction is talking about parts of a whole. Now, if we have this and we want to, like I said, be able to convert this to a decimal, you're really just dividing the top by the bottom. So 2 divided by 3 is decimal 66 repeating. 8 divided by 3, if you were to put that into your calculator, is 2.66. And you're just dividing, and again, it's repeating. It's not as easy to see when it's in an improper form, but you should recognize that the top number is smaller than the denominator. The numerator is bigger than the denominator, I should say, which means that there are complete sets in there. There are 2 wholes in there and then a few pieces left over. And it actually is the same question as this, 2 2/3. The whole number is 2. Those are not decimal numbers, that's complete numbers. And then 2/3 is decimal 66. I use the same numbers so you can kind of see how they're used. In each of these cases, if the numbers weren't the same, you would just be dividing the top by the bottom. Except for this case, you put the whole number in front of the decimal. Okay, so changing mixed to proper, this is very important because we have to use it for all of our operations. When we're doing this, we have 3 wholes and 2/5 of something left. Now, our 3 wholes are still, in theory, divided into 5 pieces. We just have 3 complete sets of 5 pieces. So in order to figure out how many, you could draw a diagram, but that's too time consuming. We multiply the denominator times the whole number, and then before doing anything else, we add the numerator, and it goes in this direction. So 5 times 3 plus 2. 5 times 3 is 15 plus 2 is 17. That becomes your new numerator. And the denominator doesn't change because we're still talking about pieces of 5. So at 3 2/5, if we want to know how many pieces of 5 we would have 17. So it's 17/5. I'll do it again. We have 2 wholes and 1/3 down here. And so we have 2 full complete sets of 3 plus 1/3. In order to figure out what that would be as an improper, we multiply and add. So going this direction, 3 times 2 is 6, plus 1 is 7 thirds. There's our improper fraction. And the last example, again, going this way, because sometimes kids go the wrong way. 7 times 6 is 42. and 5 is 47 over 6. And once we have it in this form, then we can start doing our operations with it. Not as common, but sometimes you'll be asked to change improper to a mix. So in this case, what we're really seeing is we have 15 pieces of 6. And we want to know, okay, how many whole numbers do we have in there? What is our mixed fraction from it? Well, the first thing to do is to see how many times 15 can be divided by 6 evenly. So how many times will 6 fully go into 15? And it will go in twice. If you try to go in 3 times, that'd be 18, it wouldn't work. So 6 will go into 15 twice. That becomes our whole number. And then we've got to say, okay, what are 2 groups of 6? 2 groups of 6 are 12. So we have 12 that are taken care of, but we started with 15. So all you have to do is take the difference between those. 15 minus 12 is 3. And then the denominator stays the same. We will talk about reducing that later. That actually equals 2 1/2. But that's how we do it. So we'll do it again. The first thing is see how many times 7 will go into 22 completely. That'll give us our whole number. So 22 divided by 7. 3 will go in, make it 21. 4 would be 28. So 28 is too big. It's got to be 3. So 3 is our whole number. Now 3 times 7 is 21, but I started with 22. So the difference, the stuff that's left, is 1 piece of 7. So that's how we do those. Now, what you've done in earlier grades is add these with the same denominator. Adding and subtracting must have common denominators. Multiplication does not, neither does division, but adding and subtracting does. So if your denominators are the same and you have 5 pieces of 14 and 3 pieces of 14 and you were asked, how many pieces of 14 are we talking about? We would simply add the top numbers because we are talking about 8 pieces of 14 or 8 14ths. We do not add the denominators together. We are trying to figure out how many parts of 14 we have altogether. We would not change that to 28. We only add or subtract the top numbers. And again, we will talk about reducing. That would be 4 sevenths because 2 goes into 8 and 2 goes into 14. So we can reduce that to 4 sevenths. When we get down to questions like this, for convenience sake, you should be making sure you change everything to impropers first. There are times when you could just add the whole numbers and just add the proper fractions, but many times, especially with multiplication, division, subtraction, and many addition questions, you'll make some mistakes. So what I say is make sure you change them all to improper right off the hop. So remembering, we multiply, then add, multiply, then add. We're going in this direction. So 8 times 2 is 16, and 16 plus 4 is 23 over 8, plus 8 times 3 is 24, and 7 is 31 over 8. And now that the denominators are the same, and now that we have figured out what our numerators are, we can just simply add them across. So that would be, top numbers is 54 divided by 8, and then you would be able to reduce that. Again, we haven't quite talked about it yet, but we will today. So now we start with the work where they are not common denominators. They are different denominators, and there are 2 methods. There's a simpler method when you have it looking like this, and there's a little bit harder method, not harder, just different. A method number 2 when the 2 denominators are completely different. So anyhow, the first thing you got to do is look to the denominators and see if either of those are factors of the other one. Will 15 go into 5? Will 5 go into 15? If the answer for that is yes, either way, you only have to change 1 fraction. So 15 will go into 5 because 15 is bigger than 5. So we can't go that way, but 5 is a factor of 15. 5 will go into 15 3 times. So if I want to change this denominator to 15, I would have to multiply it by 3. And you're going to multiply the top as well. So this will give you 6/15. It's just an equivalent fraction of what you had before. And this is also 6/15. Oops, 6/15. Beautiful. So now that you have 6/15 and 6/15, the denominators are the same. We can proceed. We have 12/15. That's our answer, but we are going, like I said, we are going to be reducing. And that will reduce to 4/5. When you do this one, you look, will 9 go into 3? It will not, but 3 will go into 9. So you say to yourself, what do I have to do to make 3 9? What do I have to multiply by? We have to multiply by 3. Remember, top and bottom get multiplied. So this fraction doesn't change, it's 4 9s, but this fraction becomes 3 9s. And once you have the common denominator, you can simply add across the numerator. So 4 plus 3 is 7 9s. So that's the first ones, but what we're also going to do is see what happens when you have mixed fractions. Again, I'd like you to change them to impropers first. It's a great habit to get into, and it only takes seconds once you get used to it. So 2 times 3 is 6, 1 is 7 over 2, plus 8 times 2 is 16, plus 1 is 17 over 8. Once we're at this stage, we start looking at our denominators. We figure that 2 will go into 8. 2 is a factor of 8, but I have to multiply it by 4. So I do that to the top and bottom. So we have 28, because 7 times 4 is 28, and this denominator of 8, and 17 over 8. When you add them up, you get 45 over 8. You may be asked to put that back into a mixed fraction, but in many cases, you're allowed to leave it right where it is, as long as it's reduced. Now, method 2 is the harder one. When I say harder, it's one more step. So the first thing you do is to look for a common denominator, just like before, but we figure out that 3 is not a factor of 5, and 5 is not a factor of 3. You cannot put one of these into the other one in order to just change one. So if we can't do that, we're going to have to change both denominators. You find the smallest number that they will both go into. So the best way to do that is to simply multiply this by 5 and these by 3. You multiply the fractions by the opposite denominator. So this side here is going to be multiplied by 3, and this side here is going to be multiplied by 5. And that will get us a common denominator for both that we can work with. So 5 times 2 is 10 over 15 plus 9 over 15. We have made 15 our common denominator by multiplying by the opposite denominator. And now that we have it, we can simply add it. 19 over 15. Most cases you can leave it just as it is. Some cases they may ask you to change that back to a mix. In this case, again, the first thing we do is we change it to an improper. We have to be able to do that quickly. 4 times 2 is 8, plus 1 is 9 over 4. And we're going to change this one. So 5 times 3 is 15, plus 4 is 19 over 5. Now, these numbers might get a little bit big, but it shouldn't be anything that concerns you too much, because we can do larger numbers. So we find out that 4 won't go into 5 and 5 won't go into 4. So we're going to look for the smallest number that they will both go into. The best way to do it is just to multiply by the opposite denominator. So these sides will get multiplied by 5, and this number in the denominator will get multiplied by 4. So 5 times 9 is 45, and 4 times 5 is 20. And again, this is 20, and that's 80 minus 4 is 76. So I do a little mental math there. When you add those together, I see 110, 121. over 20. You can leave it, or you can say 6 and 1 point, depending on what the question asks you. So that is our work for today. And what is important to note is it only says adding on these titles, but we talked about it. And this is true for adding and subtracting. So as soon as we're done with method 2, we are going to subtract as well. So adding and subtracting are the exact same rules, exact same steps. You must have common denominators for both. Okay. Deep fraction.